graphics, and for numbers I'll term it as will term it as production possibility schedule, and then we will draw a curve from that schedule. First we will take the schedule thing into consideration. So if we have to define the production possibility schedule, is the tabular representation, okay, or the numerical representation. As we have been defining production possibility curve, what we said, production possibility curve is a graphical representation. So what we can write here is production possibility schedule is a tabular representation of all possible combinations of goods which we can produce with given resources, etc., etc., from the very first definition. So it is a tabular representation. And contrary to production possibility curve is the graphical representation. So if you are being asked to define either of the two, how does it looks like? See, we said that in order to produce one good, we have to sacrifice the other good, because the resources are given and technology is given which we cannot change. So how we can show it? It is very simple. Now for you people, keeping all those very things in mind what we were talking about, we can do one thing. We can draw a production possibility schedule or table. So what does it look like is, let us take first column as production possibilities, okay. What are the two goods we have been talking about is wheat, and second is tanks. So these are the things we have to talk about, okay, we are talking about. So students, as you can see, I have divided this table into three parts. First is production possibilities, other two are the two goods which we are talking about. Fine. So let us name the possibilities first. Say we have a possibility A, which says if we employ all our given resources on the production of wheat, we will be on the production of tanks or wheat, we will be able to produce, let us say, 15 lakh tanks or 1000. Let us say this is in thousands, this is in wheat is in lakhs of tons. That means if all the resources in an economy are employed to produce tanks only, we'll be able to produce 15,000 tanks, but we won't be able to produce any wheat. There is one more possibility that we can make a trade-off in between the two things. Now the economy wants to produce some wheat. Let us say they want to produce 1 lakh tons of wheat. So it is obvious that now the resources have been shifted from the production of tanks to the production of wheat. The production of tanks will decrease. We have one more possibility. We can produce more of wheat. We will be able to produce less of the tanks. Let us take one more combination. 1 more lakh tons of wheat, more less of tanks. Let us take one more, 4, okay, this will decrease more. Let us take last one as 5, and here we will, if we are producing 5 lakh tons of wheat with the available and given resources and technology in the economy, we won't be able to produce any of the wheat. As you can see here in this very table, this is quite evident that if all the resources are employed in the production of tanks, 0 of wheat will be produced, and if all the resources are employed in the production of wheat, 0 of tanks will be produced. So there in between there is a little trade off in between the possibilities we are talking about. But you will come to know why the change is just not very similar. Here there is a difference of 1, we have a difference of 2, the difference is increasing, we have a difference of, let us say, 3, we have a difference of 4, we have a difference of 5. Why is this happening? This is to be answered separately. But what we will concentrate on is the production possibility schedule, and from this production possibility schedule we can make a production possibility curve now, which will tell us a lot about the things or the features which we were talking about. So keeping in mind all the above combinations, let us take 2 axes, because we have to draw a graph now. Okay, fine. We have to take 2 axes. Let us take 2 axes like this. I'll have to work out a few things for you people, because I don't need other quadrants. What we need is this much only. So what is happening here? And looking on the table, we have wheat and we have tanks. We can take any these 2 things on our given axis, that is x-axis, y-axis. Let us take tanks here on y-axis. This is origin. This is origin, and from x-axis let us take wheat. Now before we scale our graph, let us go back to the table and look at it. Under the wheat section we have highest 5, lowest 0, and under the tank section we have highest 15, lowest 0. So our scale should look like from the wheat side as 1, 2, 3, 4, 5, fine, 6, so on and so forth. And from the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can distribute it evenly as well. Let us do that only. That will help you to bifurcate it properly or to look at it properly. This is our 1, 2, 3, 4, and 5. Now it looks more simple and beautiful. From the tanks we have lowest 0, highest 15. So 0 is already here. 15, 3 5s are 15. We will take a scale of 3, 6, 9, 12, and it will come as 15 here. Fine. So now let us put some locuses or combinations in order to draw our curve. If we are producing 0 of the wheat, we will be able to produce 15 of the tanks. If we are now increasing the production of wheat to 1, and we will only be able to produce how many of, okay, 1 to 14 of the tanks. So that says that this is 12, in between 12 there are 3, this is 1.5, 14. It will come somewhere, this is 1, it will come here. Okay, 2 of the tanks, 12 of the 1 with 14, 2 with 12, 2 of the wheats and 12 of the tanks, 3 of the wheat, 9 of the tanks, 4 of the wheat, 5 of the tanks, 5 of the wheat, 0 of the tanks. So now we will try to join these points with a curve. This is how your curve will look like. So these all things we have been talking about, these are the possibilities, these are the combinations here on this production possibility curve. So from the properties of the production possibility curve, features of the production possibility curve, we are here now able to explain it. Yes, we were right that a production possibility curve is a downward sloping from left to right. You can see on the graph it is a downward sloping curve from left to right. Okay, downward sloping from left to right. This is the important thing. You please bear it in mind. But for now, what we got is called a production possibility curve. This curve is known as production possibility curve or production possibility frontier. So it is a border under which we have to remain or on which we can remain at the most. So dear students, here we can proceed with one more thing, that this production possibility curve is possessing certain properties, and those properties are going to explain us that what we are talking about. The first and foremost property is from the features itself, is that it is downward sloping from left to right. The second property is saying that in the features itself that it is concave to the origin. Production possibility curve is concave to the, refer back to the features which I wrote just a short while ago, concave to the origin. See, this is origin here, okay. This curve is concave to the origin, see, concave to the origin. If it would have been convex, the shape would have been like this, to the origin. But what is our shape? It is downward sloping from left to right and concave to the origin. And this concavity comes from exactly the increasing marginal opportunity cost. That is what I was talking about here. Let me, for you people, do one more thing. I'll add, after completing the production possibility schedule and production possibility frontier, I will add up one more column to this scenario, to this very discussion, where we will now add it with one more column to calculate our exactly the third thing, marginal opportunity cost of wheat or marginal rate of transformation. It is one and the same thing. How? For you people, we do not need, but for you people, I will put in one more column to make it more definitive for understanding of yours. And I'll name these two columns as, first one, marginal opportunity cost, of wheat, okay, and this is what we are concerned about, basically the marginal rate of transformation for the formula, for which the formula was delta tanks over delta wheat. Why I took delta tanks and delta wheat? Because we are losing tanks, gaining wheat, sacrificing tanks, obtaining wheat. So the sacrifice thing is kept above. So how we do it? See, in the very first combination, where we are able to produce 0 of wheat and 15 of our tanks, marginal opportunity cost cannot be evaluated. It will be put as a blank. But at second level, what we are doing, we are having 15 of tanks from the very first combination. Now we are sacrificing 1, that means we are producing just 14 tanks, which will come equal to 1. Likewise, at the second stage, 14 minus 12 is equal to 2. Third stage, 12 minus 9 is equal to 3. Then 9 minus 5 is equal to 4. And then this 5, okay, minus 0 is equal to 5. See, 14, 12, 9. Fine. Now let us see in terms of marginal rate of transformation what is happening. What we calculated here, this 1, 2, 3, 4, 5 is the marginal opportunity cost. What we have to calculate now is marginal rate of transformation. How it is done? Okay. First, it cannot be evaluated because no loss, no gain condition. All the tanks are being produced. 15 of the tanks are only producing. But at the next stage, we are sacrificing 1 tank to produce 1 wheat. Change in tanks from 15 to 14 is this 1, and change in wheat from 0 to this 1 is here. Understood? So it will come equal to 1 by 1 is equal to 1. Then we are sacrificing 2 tanks to obtain 1 of the wheat, 2 by 1. Okay. Next is 3 by 1. Next is 4 by 1. And next is 5 by 1. So this is how it is calculated. It is the ratio here. 2 by 1 is the ratio, 3 by 1 is the ratio, 4 by 1 is the ratio, 5 by 1 is the ratio of the units sacrificed to the units gain. So this is how we calculate our opportunity cost as well as the marginal rate of transformation. As you can see in this example also, that marginal opportunity cost is increasing. That is what I mean by marginal rate of transformation. That is also increasing. You see 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1. So this is increasing marginal opportunity cost. This gives us one more hint or one more thing, or we can now here talk about the reasons for increasing marginal opportunity cost. Let us talk about the reasons so that we may understand something more. Keeping in view this diagram of ours, what are the reasons that our marginal opportunity cost is increasing? Remember, production possibility curve is based on the law of diminishing returns or increasing cost. This you won't understand this time. We will explain it later on in the next few next few days. But for this class, you keep a few things in mind, that transferring resources from more productive to less productive use is one reason, the most important. You know what happens that when we are shifting the resources from the production of tanks to the production of wheat, from the production of tanks to the production of wheat, what is happening basically that the resources are not equally efficient in the production of wheat. Say we were producing the tanks, the resources which we employed is labor. We shifted some labor from the production of tanks to the production of wheat. The first 10 laborers which we, or first 20, first 30, first 100, first batch, first factory of laborers, they were a bit efficient enough to produce goods in the fields. That is, they were good farmers. The second batch was not equally good, so they produced less. We are producing only one additional increment here, while we are losing here the loss is increasing from 1 to 2 to 3 to 4. So this is what you have to keep in mind. These are the reasons behind that marginal rate of transformation is increasing. So dear students, after we are now able to understand what is the production possibility curve, what is the production possibility schedule, and what is marginal opportunity cost and marginal rate of transformation, we now will come on a very small and simple thing that is known as the shift in the production possibility curve. The shift in the production possibility curve, does it take place, how it takes place? These are the things before we answer many more things. Production possibility curve is downward sloping if you are asked why. So the simple answer is production of one good can be increased. Production of X can only be increased if you are decreasing the production of Y. These are the reasons. Production possibility curve is concave to the origin if you are being asked a question. Okay, so it is due to exactly increasing marginal rate of transformation, and rest you will give the mechanism. Why is production possibility curve concave to the origin? Because the marginal rate of transformation is increasing. Why is production possibility curve downward sloping? Because in order to produce one more unit of good X, you have to sacrifice the production of good Y. In order to answer our basic three questions, this is what is required to do. Production possibility curve offers various options to the society. These are the options here: A, B, C, D. Not only A, B, C, D, we have started it from the origin itself. So we can say our option is here in white: A, B, C, D, E, F. So production possibility curve, what to produce is getting answered now. What to produce is getting answered now. Is providing the society with different options in form of different combinations. See, C is an opportunity. Okay, C is a possibility, which is a combination of this 12 and let us say this 2, or 10 to whatsoever is from the table. E is a combination of 4 and from here 5. So C constitutes how many? 12 of tanks and 2 of wheat. It becomes a combination now. C is a possibility which has a combination of 12 and 2. E is a possibility. That is what it is named as production possibility. C, E, D, A, B. E here is a production possibility which is on the curve. That is why it is called production possibility curve, which has a combination of 5 of the tanks and 4 of the wheat. This is how it works. E is a possibility, 5 and 4 is the combination in it. How to produce can now be easily answered. That the technique of production employed here is, if we replace tanks with wheat, or if we replace tanks and wheat with labor and capital. Now employ it, name this as labor and this as capital. Work out your schedule and see more of labor, here less of capital, less of labor, more of capital. For whom to produce? Now this is also getting answered. In our case, this is answered in, say, we are producing tanks, we are producing wheat. Tanks are being produced as defense goods. Wheat, let us take it as civil good. In combination E, we have more of civil goods and less of defense goods. While in combination C, we have more of defense goods and less of the civil goods. So this is how you can answer all these very questions. Now you must remember in mind that I'll draw for you people one more graph to make you understand that how it works. For that, I'm taking the coordinate axes. Okay, so we are using just 2 coordinates, so we do not require this much of the graph. First, let us name the graph. It is origin here. Okay, we have taken wheat and tanks. I won't number the graph this time because I do not require it, as you are now well able to understand. So let us take a production possibility curve. This is a production possibility curve, downward sloping concave to the origin. And let us take 2 combinations in this very production possibility curve. Let us take this and this makes one combination. Let us name it as A. This and this will give us second combination, that is B. Either we are going from A to B or B to A. Let us say we are decreasing the production of tanks from Y to Y1 and increasing the production of wheat if we are decreasing the production of tanks. So combination was Y, this was our X, Y1, it is increasing to Y, X1. But see, we are decreasing the production of, inside the graph, we are decreasing the production of tanks and we are increasing the production of wheat. By decreasing one, we are able to increase the other. This is also the answer for your production possibility curve and opportunity cost if you take together. Okay, for the time being, we are going from combination A to combination B. Combination A has got Y of tanks and X of wheat. Okay, while combination B has got Y1 of tanks and X1 of wheat. You can replace it, like it is nothing to worry about. Say A is a combination in which we have Y is for tanks, T tanks and W wheat, while in B we have T1 of tanks and W1 of wheat. So I am just replacing, renaming the things and nothing else. So we are done with the opportunity cost as well, is an activity of the best alternative foregone. So dear students, here now we will come to the last thing which we have to talk about, is the shift of production possibility curve, and we will take a few questions into consideration whether it is possible or not. The shift can occur in different ways. It can be a leftward shift and a rightward shift. Let me draw two production possibility curves for you people in advance. This is my y-axis, this is my x-axis. It is basically read as y-axis upon x-axis. Okay, I'll take x, y, origin, x, y, origin. Okay, so let us draw two production possibility curves also. This is our production possibility curve in this very case, and this is our production possibility curve in this very case. Okay, so what is happening in both the two cases, I'll tell you. What I am teaching this time is shifts. Okay, shift. Here I'll show you people the rightward shift. Here I'll show you people the leftward shift. Rightward shift means that production possibility curve will move rightwards. That means in this direction, from here to here. Leftward means that production possibility curve will move in this direction. That means from here to here. Okay. Why is rightward shift taking place and leftward shift taking place? Production possibility curve represents various combinations of two goods that we know, which can be produced with full and efficient utilization of given resources. Clearly, the production possibility curve can shift. It can shift in many cases. Let us take the rightward shift first. Why it is taking place? Suppose our resources got deteriorated or got increased, or let me take only one thing to make every example clear. Let us take technology. What is applicable here is applicable everywhere. You can correlate now things. Case first, case second. Let us say technology in case of case first, figure first, progressed. We have here technological progress. When technology progresses, production increases. But it is not saying technology progressed for wheat or for tanks, for good Y or for good X. It is saying technology progress took place, or increase in supply of resources took place. The resources increased. Okay, what will happen? We will be able to produce more of both the two goods, more of X as well as more of Y. So our production possibility curve will take a shift like this. We can also name it. Our first production possibility curve was PP, and our next production possibility curve is P1, P1. So the shift took rightwards from PP to P1, P1. So outward shift, rightward shift due to technological progress. And let us make opposite of it. In the case of our second diagram, a leftward shift has to be made. How it will take place? Let us say technology is not increasing, it is, let us say, deteriorating. Technological deterioration took place, or the decrease in supply of resources took place. Okay, due to flood, due to lockdown, or anything else, due to a war. What will happen? We will now be able to produce less of X and less of Y. So our PP curve in second case will shift to P1, P1, and our production possibility curve will be like this. It is an inward shift. because our production possibility went from PP to P1, but inwards. This is outwards or rightward. This is inwards or leftwards. This is how shift takes place. I took an example of technology, so now you can correlate all these very things. So dear students, there are certain reasons which you must bear in mind for the leftward and rightward. So I'll name the reasons only. I do not require to enlist them. See, for the rightward shift, production possibility curve will shift from to rightwards only when, say, you have availability of new equipment, or you have availability or increase in skilled labor, or you have discovery of new natural resources, or you can say you have better technology or technological progress now. And the leftward shift will take place only when you have opposite of that, is you have wear and tear or breakdown of machinery. Okay, the production process is going on, some of the machinery is broke down, so it is obvious that production will decrease. Or you have saturation of some natural resources. Okay, or you have non-availability of equipment parts or skilled labor, or your technology becomes obsolete, as I was saying. There are other possibilities. Let us take a few cases and wind up this production possibility curve, which will not only make you the production possibility curve to shift, it will make the production possibility curve to rotate as well, or move from on one axis only. For that, let us take a few examples. I'll make a few cases. Okay, let us take a few cases. T for technology increased, it will be a bit difficult for you like this. I'll write it in full form. Okay, case first. Technology advanced in favor of good X. Number second case. Supply of resources increased in favor of good Y. Number three. Technology obsoleted in favor of good Y. Number fourth, supply of resources and technology deteriorated. That means supply of resources decreased and technology deteriorated in favor of good X and Y respectively. How we would perform these cases, how we would do with these cases? It is very simple. Now for you people, after understanding all this is a production possibility curve which I am going to draw. Name it x-axis, never forget to name it origin. Draw the curve, downward sloping concave to the origin curve. This is our basic diagram. Now let us take the first case. Technology advanced in favor of good X, but this is, here we are producing good X, here we are producing good Y. Okay, it is saying technology advanced in favor of good X. It's not talking anything about good Y. This is our good, what happened to it? This is our good X. what happens? That means we will be able to produce more of good X from X to X1. But it's not talking anything about good Y. So we'll be able to produce same of good Y. So this thing will happen like, I'll use another color. This will be our new production possibility curve. Our first production possibility curve, let us say, was P, and our new production possibility curve is P is same and P1. So we have P and new production possibility curve as P1. This could happen. Let us take one more case. Name the axes: x-axis, y-axis, origin. Draw a production possibility curve, downward sloping. Name it P. So here we are producing good X, here we are producing good Y. Second case is supply of resources increased in favor of good Y. That means we will be able to produce exactly more of good Y, and good X is at the same level. So what will be our next production possibility curve will look like? This will be our next production possibility curve, the dotted line. Okay. Now take another case which says technology obsoleted in favor of good Y. I'll do it on the same graph. Technology obsoleted in favor of good Y. That means we will be able to produce less of good Y now, from P to P1. Okay. Let's name this P1. Technology obsoleted in favor of good Y only. He is not talking about good X. So good X is same. So our production possibility curve will look like, this will be our production possibility curve. Or last but not least, for that I'll take a new production possibility curve which will look like, it becomes a bit, okay, I'll take a new production possibility curve for you people so that it may remain in your sight and we may at the same time draw the PP curve. So the new production possibility curve will look like, this is the last and fourth case I am talking about. Okay, dear students, please keep in mind what I am doing. I'll name it y-axis, x-axis, origin. Okay, I'll draw a production possibility curve. This is our production possibility curve. This is the basic diagram. Okay, we require this basic diagram to further work, and further whatsoever we will do, we will show it by, we will show it with the help of a dotted line. So what is happening here? Supply of resources is decreasing and technology is deteriorating in favor of good X and good Y. So supply of resources is deteriorating in favor of good X. So we will be able to produce less of X, and supply of in favor of good Y. Supply of resources is deteriorating in favor of good X, and technology is deteriorating in favor of good Y. So we'll be able to produce less of good Y also. So how it will happen? It will happen like this. So here we have our final production possibility curve. So here I'll take a leave of yours and be happy. God bless you all. We are done with the production possibility curve. It shifts. This was one more topic which